everyone, and welcome back to another Auto Alfred video. It's not an Auto Alfred video. Embarrassing. Cut. Hey everyone, and welcome back to another sensational science video. Now today, we are back with another space topic. This time it's about auroras. An aurora is basically in exactly the same as a northern light. It's just another name for it. Or the southern lights, so you can see them at the north of, well, somewhere near the north of the Earth, or the south part of Earth. So, enough of talking about like where you can see it. Let's just get on with the video. So, an aurora is formed by the sunlight being captured by the Earth's magnetosphere. There's a ring at the north and the south of the planet where it would be most likely to see the aurora. When the sunlight gets captured, it will turn around back towards the Earth and hit the two rings at the north and the south. Electrons will hit the air molecules, and the air molecules that gets excited will show the lights of the aurora. Usually, auroras are most visible at night during the winter. It is obvious that it appears at night more clearly because during the daylight the sun would be too bright to see the aurora. And by the way, the sunlight is not the same as the aurora. That's obvious. Okay, let's move that on. It is most visible at winter because night lasts longer during that time. This means you'll have more time and therefore more chance to see the auroras. The aurora's colour is usually told by the air molecules that the electrons hit. So if the electrons hit an oxygen molecule, the light will appear either greenish, yellow, or red. A bit like the diagram on the right, you can see the top left or the bottom two pictures if it hits oxygen. But if it hits a nitrogen molecule, the light will usually appear blue, like the top right on there. The aurora will usually appear as a white light as the aurora gradually gets brighter. This is because your eyes have to adapt to the dark, and it usually takes time for that to happen. However, if you point your camera at the aurora, it will appear as a coloured light, usually green, because that's the most common colour of an aurora. Sometimes they're very dim on the camera, just like the ones I've taken on my camera. On the right two pictures, you can see they're very dim. But if you're lucky, the aurora, I can't pronounce it, the aurora will get even brighter than what I've taken, and your eyes will finish adapting so then you can see the coloured light of the aurora. There are four main types of auroras: arcs, bands, pillars, and corona, not coronavirus, just saying. If you want to know more about that, then there's a video that I've made. Click on the top right. They're small but tough. Anyway, the arc is a curved type, bending from one side of the horizon, rising up towards the centre, and drooping down on the other side of the horizon. It's basically like a rainbow, except it's not a rainbow, it's an aurora. The band type has a shape which resembles what you may usually think of an aurora, so it's a ribbon-like structure which bends around like a snake. Got two pictures on the right there. You should be able to order them. I've put them on the wrong way around to confuse you. Now the pillar type can be described in exactly that word, a pillar-like structure. Nothing really else to say about that, that's it. And now the corona is what every aurora watcher is dreaming to see. Unlike with the coronavirus, nobody wants to see that. This type of aurora is extremely rare and very special. It is similar to the pillar type, but it bends around a lot, just like the band. It really is a spectacular view. You can see the picture on the bottom left. It looks great. And in fact, it's so special that it's been given a particular name for it. It's called Aurora Corona. Nice. Auroras absolutely can happen on different planets. They usually happen on every other planet in the solar system apart from Mercury because the magnetosphere is too weak there. Now there's a scientific name for what a solar system is called. Do you want to know what that is? Well, click on the pop-out banner in the top right to find out. and then you'll see. So, okay, carry on. Because the gases in the atmosphere of the other planets are different, obviously, the auroras appear to be different colours there. For example, auroras in Jupiter appear blue. Saturn's auroras can be also blue or red. Uranus's auroras appears blue, but you can't see it very clearly because the planet itself is blue. Same with Neptune. Neptune's auroras appear green or blue. And finally, Venus and Mars have very strange auroras. They're very complicated, so I can't tell you about them now. Otherwise, it'll make the video way too long, and you don't want to. And you don't want that, don't you? Anyway, here's a quick gallery of all of the different auroras on other planets, and of course our own planet ourselves. Looks amazing, doesn't it? Because I put all of the pictures on this slide, it does mean that the previous slide was a bit boring, so sorry about that. But anyway, that is it for this video. I hope you enjoyed it. If you did, please like the video, subscribe to the channel if you're new, to see plenty more of these science videos. Once again, as I said before, if you do want some different types of videos other than space, then comment below. Until then, I'll see you next time. And also, a video will come out every week on Sensational Science. So, yeah, they will usually happen on Tuesdays or Wednesdays. So, see you next week, I suppose.